Myself BL Deepan, Senior Lecturer Electronics, Government Polytechnic College, Jodhpur. सेकेंडरी इलेक्ट्रॉनिक्स के सब्जेक्ट इलेक्ट्रॉनिक डिवाइसेस एंड सर्किट्स की यूनिट रेक्टिफायर एंड पावर सप्लाईज के टॉपिक पावर सप्लाई एंड फिल्टर के अंतर्गत इंडक्टिव और एलसी फिल्टर को आज डिस्क्राइब करेंगे। सीरीज इंडक्टर फिल्टर, सबसे पहले लेते हैं सीरीज इंडक्टर फिल्टर विद फुल वेव रेक्टिफायर। Inductive filter is connected at the output of full wave rectifier, which is further connected in series with the load resistance. Series inductor filter. An inductor has the fundamental property of opposing any change in current flowing through it. This property is used in the series inductor filter. Inductor की ये property होती है कि it opposes any change in the current which is flowing through it. Whenever the current through an inductor tends to change, a back EMF is induced in the inductor. In this circuit, inductive reactance is equal to Ri and inductor reactance Xi is equal to 2 pi FL. Here this is a full wave rectified output waveform, and this is the output voltage which is obtained at the output of inductive filter. This is VDC, which is equal to 2 Vm by pi. When the output current of the rectifier increases above a certain value, energy is stored in inductor in the form of magnetic field, and this energy is given up when the output current falls below the average value. When input is rises, output is decreasing. When input is decreasing, this current is increasing. Thus, by placing a choke coil in series with the rectifier, output and load, any sudden change in current that might have occurred in the circuit without an inductor is smoothed out by the presence of L. DC voltage across load VL is equal to VDC into RL upon RI plus RL, which is equal to VDC upon 1 plus RI upon RL. If RI is much less than RL, then VL will be equal to VDC. Fourier series for the rectified output voltage is given by VL is equal to Vm 2 by pi minus 4 by 3 pi cos 2 omega t minus 4 by 15 pi cos 4 omega t. This is a DC component, this is second harmonic component, this is fourth harmonic component. Fourth and above harmonics can be neglected. Maximum value of the voltage drop across load resistance RL due to second harmonic voltage is given by Vc max is equal to 4 by 3 pi Vm multiplied by RL upon square root RL square plus Xi square. Therefore, RMS value of the AC voltage drop across load resistance RL, VAC RMS is equal to 4 by 3 pi root 2 multiplied by Vm multiplied by RL upon under root RL square plus Xi square. Ripple factor then will be equal to VAC RMS upon VDC, which is equal to 4 by 3 pi root 2 Vm RL upon square root RL square plus Xi square upon 2 by pi Vm. VDC equal to 2 by pi Vm, which is further equal to root 2 by 3 RL upon square root RL square plus Xi square, which is equal to root 2 by 3 1 upon square root 1 plus Xi square upon RL square. Here output frequency is equal to 2 Fi, Xi is equal to 2 omega L is equal to 4 pi FL. Therefore, ripple factor is equal to root 2 by 3 1 upon square root 1 plus 4 omega square L square upon RL square. And finally, the ripple factor is equal to root 2 by 3 RL upon 2 omega L. If we assume if 2 omega L is larger than, is much greater than RL, in that case it is equal to RL upon 2 omega L. And finally this comes out to be RL upon 3 root 2 omega L. Therefore, formula for ripple factor is equal to RL upon 3 root 2 omega L. From this formula, it is deduced that ripple decreases with decrease in RL or increase in load current. So inductor filter is more efficient for higher loads. If load is decreasing, or we can say RL is tending towards infinity, open circuited condition, in that case ripple factor is equal to root 2 by 3, which is equal to 0.471, which is nearly equal to a ripple factor of a full wave rectifier. Now let us take LC filter. LC filter is connected at the output of full wave rectifier. It is L, it is C, which is in parallel with it is in shunt with the load resistance. It is inductive filter which is in series with the rectifier. This type of waveform is obtained at the output of or output across the load resistance. The choke L on the input side of the filter allows DC to pass and flow of AC components, because its DC resistance is negligibly small but AC impedance is large. Any fluctuation that remains in the current even after passing through the choke are largely bypassed around the load by the shunt capacitor, because XC is much smaller than RL. Ripples can be reduced effectively by making XL greater than XC at ripple frequency. This formula VL is equal to 2 by pi Vm minus 4 by 3 pi Vm cos omega t. From this formula, VDC equal to 2 by pi Vm if inductor has negligibly small resistance. In order to suppress the harmonic component in the filter, XL should be greater than parallel combination of XC and RL. XC and in between XC and RL, XC is much smaller than RL. Higher value of C results in low value of the XC. Therefore, and XL is equal to 2 omega L. Therefore, IAC RMS equal to 4 by 3 pi Vm upon root 2 XL, which is equal to 2 root 2 by 3 pi Vm by XL. Therefore, IAC RMS is equal to root 2 by 3 VDC upon XL. The AC voltage across the load ripple voltage is equal to the voltage across the capacitor. VAC RMS. Here we have obtained IAC RMS. Now multiply it by XC, reactance of the capacitor, we will get VAC RMS, which is equal to root 2 by 3 VDC XC upon XL. Here XC is equal to 1 upon 2 omega C. Ripple factor then equal to VAC RMS upon VDC, which is equal to root 2 by 3 XC upon XL. Therefore, ripple factor finally becomes root 2 by 3 1 upon 2 omega C multiplied by 1 upon 2 omega L, which is ultimately equal to 1 upon 6 root 2 omega square LC. Now, by taking the value of L equal to 100 millihenry and C equal to 1000 microfarad, at frequency omega equal to 2 pi f is equal to 100 pi, we can find out the ripple factor value by formula 1 upon 6 root 2 omega square LC. In this case, ripple factor will be equal to 0.01195, which is much smaller than ripple factor of the full wave rectifier. So this circuit is more effective than simple inductive filter and capacitive filter. Thank you.